All right, so bullet striking the block, and it makes the block swing up to some higher position, right? So let's draw our requisite pictures, right? We need to draw three pictures. So we've got bullet strikes block, right? Bullet's moving, block is sitting still, right? In the next picture, the bullet has, this is our slightly fictional picture, right? The bullet is stuck in the block, but the block hasn't moved at all, right? And then in the next picture, the block has risen some distance, right, on these strings. And of course, from here to here is energy is conserved. From here to here, momentum is conserved, right? So let's figure this out, right? So point 0.125 is the mass of the bullet. It's going 516. The block isn't moving, right? And let's use momentum from here to here, right? So m times v plus 0 is equal to, what is this? This is 0.0125 plus 1.625. We got to figure out the mass of the bullet and the block, right? So 0.0125 plus 1.625 is 1.6375. Did I do that right? I think I did. Just double check here because it's so sad. Times v, right? So let's figure out this v. V equals, okay, so 0.0125 times 516 divided by 1.6375. All right, did that work? Yeah, I get 3.93893 ... meters per second, right? Okay, which is about 3.94. So we circle that, right? And then we have to do energy, right? So in this case, we're going to say 1/2 mv squared. So 1/2 1.6375 times 3.93893 squared equals, and then in this case, mgh, right? So 1.6375 times 9.81 times h, right? So the formulas are 1/2 mv squared turns into mgh, right? This is just conservation of energy, a one-to-one, a pretty simple one, right? Okay, so now notice that the mass will cancel, so I don't actually have to use that mass. Use it or don't use it. I'm not going to use it. So I'm going to go 0.5 times that number squared divided by 9.81. And I should have h, right? And I get that h is equal to 0.790783, right? So you'd say h is, in 3 sig figs, you'd say 0.791 meters. That's pretty far. I mean, that's almost a meter up, right? Okay, so again, in the first collision, momentum is conserved. In the swinging up, kinetic energy turns to potential. Okay, just don't turn this kinetic energy into that potential, because in this collision, as we know, a lot of energy is lost to the heating up of the bullet and the ripping of the wood and all these things. Okay.